Hello, and welcome to chapter 6, folks. This chapter, we're going to talk about the supply curve and how producers make their decisions, right? So, in the prior 3 chapters over last week, and continuing on this week, because this chapter will overlap with the elasticity chapter for most of you. What you're going to find is that now we're embarking on how does the farmer make a decision about what they're going to produce. So just kind of sit back. There's going to be a lot of numbers, but the arithmetic's fairly simple. A lot of graphs and tables, and we'll kind of go through those. Feel free to reach out via email or text my cell phone if you've got any questions about this material or need any expansion. So as always, we've got our, sorry about this. We've got our learning objectives. I'll let you take a quick screenshot or pause to read through these and see what we're going to discuss. So nothing too groundbreaking here. So first off, we've got some conditions for perfect competition. So we're going to talk about non-perfect markets later on in the semester, but right now we're going to assume that there's perfect competition. And agriculture is one of the few areas left in the economy where there still is somewhat perfect competition, right? So economists and politicians like to talk a lot about perfect competition, but there's some constraints that exist for that to occur. And we're going to go through these one by one. And what you'll see is that it's very difficult, even in the modern era, for agriculture, for example, to even be counted as perfectly competitive market, but it's still pretty dang close. So first off, we've got that all of the products have to be what are called homogeneous or homogeneous. So what's that mean? It means that they have to be identical or at least perceived as identical, right? So case in point is two heads of lettuce might not be identical. But if the consumer, from their perspective, views them as identical, then they are the same, right? So this gets problematic, right? Because it used to be that you'd go to the grocery store and there wasn't a lot of discussion about anything. And as long as the food in the produce section or on the meat counter wasn't rotten, people didn't really think much about quality distinctions or differences or where it was produced or who produced it. In fact, most grocery shoppers, as recently as even 20, 25 years ago, only were concerned about the price, right? But in a modern grocery store, people are concerned about things. And so not all lettuce is the same, right? And so you might have people looking for organic lettuce. So that would be a different market than the market for non-organic products, right? Looking for non-genetically modified versions or non-GMO, that's a different product again. So every time you create a different product, you've created a lack of homogeneity, right? And so agriculture at a fundamental level is still traded in the futures exchanges, at least for the grain crops and hog futures, cattle, things like this. And so there's actually specifications that they have, like you need to have #2 dent corn to be able to sell on the exchange for Chicago Mercantile Exchange, for example. Or you need to have a certain variety of cotton. Don't know that industry as well. For cattle, you need to, it's done based on weight and then the type of steer you have. So it's fairly, the markets have created homogeneity, but at the retail level, that homogeneity is more and more falling apart. And that has implications, as we'll see later in the semester, when we talk about imperfect markets, where farmers can seek to gain an advantage, right, over other farmers by just convincing people their products are different or actually producing a different product, right? And so we'll talk about that later. But right now, we're going to assume these homogeneous products. We're going to assume these large grain crops, for example, or just hog futures, pork belly, things like that. The next one is that there has to be not really no barriers to entry exit, but there have to be low barriers to entry exit, or relatively low. So there's nothing barring a producer from producing corn or other crops and livestock, right? So I've got a friend with 12,000 acres in Merced County. His family's done pigs. They did hogs traditionally up and through really, I think the 70s or 80s when he was a child, first born. Then they switched over to cattle production. And then I guess it was about a decade ago, they switched over to doing wheat and walnuts, and some other crops, right? So, but wheat and walnuts being the two big crops that they're using right now. So there's nothing really barring you except the own economic conditions on your farm from producing certain things, right? So maybe you don't have the land to sustain certain types of crop production, for example. But you know, the barriers to entry exit could also be maybe financial. It's too expensive, right? That's one of the arguments with farming. Maybe the land cost has gotten so expensive, you just can't be a farmer anymore. I have my son-in-law, my daughter's fiance, she lives out in Colorado with him. He wanted to be a rancher. He worked as a cowboy for quite a few ranches in Colorado, doing horses and cattle and whatnot. And what he found was that most of the ranches he worked for, the ranchers themselves didn't even own the land. They were leasing the land from far wealthier individuals, right? I might have talked about them in a prior chapter. And so the idea behind this is the barrier to entry has gotten quite large, but you know, people can still get creative. If the barriers to entry keep climbing and it becomes more and more expensive to enter agriculture, then eventually we might say, look, finances can become a barrier, right? And so it could limit the ability of new producers to come online. It could limit the ability of producers to switch crops, right? As well. Maybe, you know, and we can look at country level regulations that might bar producers from switching crops as they see fit. But in the US, for example, most farmers get to choose where they want to do soy or wheat or corn or cotton or whatever based on the actual comparative advantages that they have in their own production. There has to be a large number of sellers. There also has to be a large number of buyers as well. Not an equal number of buyers to sellers, right? We tend to have fewer sellers than buyers, but we can meet that condition in the US. There's a lot of farms, right? Currently over 2 million farms. And when you go back to chapter 2, what you find is about 10, 15%, which is still a large number, 20,000 or so farms produce a lot of the value, right? But that's still a large number. In some research on anti-competitive behavior, what constitutes enough businesses, one market tends to need to have 4 producers, depending on the size of the market, but 4 producers per market to make a competitive market. And I would wager in most agriculture communities, there's more than 4 people producing each of the types of products available for sale in the local market. At a national level, there definitely is. And then we need to have perfect information. What this means is that it doesn't mean you have to, the buyer and the seller, or the buyer or the seller has to have all information. They just have to have the ability to find the information, right? So we're really talking about transparency, right? So maybe there's some information collection costs that make it not feasible to collect that information, but even if the information's out there, then we're good to go. So these are 4 conditions that we have to meet perfect competition. If any of these conditions don't exist, then we need to recognize that a perfectly competitive market doesn't exist, and we'll handle that, as I said, later in the semester. So we can classify our inputs. I'm old school. I tend to call these factors of production, right? But we also can call these resources. And so we have land, labor, capital, and management. You'll see some textbooks, they'll call land natural resources. They'll call labor human resources, right? Or human capital. We'll call land natural capital, so you can use resources or capital. And then we'll call capital financial capital or equipment. And then we also have management. A lot of textbooks tend to not use the term management. They tend to talk more about entrepreneurship, which is really a code word for like risk, right? But it's also the structure of production itself, right? There's a lot of different ways we can think about this management. So we can think about the structure of the business operation, the types of technologies used, but we can also think about risk and risk appetite amongst the management, things like this. So it's kind of a catch-all term. In more traditional textbook outside of agricultural economics, we tend to break that management sector down actually into risk / entrepreneurship and technology, right? Is the way we tend to refer to it. So just in case you ever take another class and you're like, where's that management layer for inputs? It doesn't exist generally in economics. It's the way ag economists talk about it, not normal economists. I guess normal is the wrong word, but general economists, let's put it that way. Okay, so we can take all these inputs or resources or factors of production, and we can put them into what's called a production function, right? And so the production function just is the output, and your book uses O, but as said, I'm a little old-fashioned. I use Y for output. So if I ever write something out or you're working with me in office hour type setting, you might see me write Y equals, and that just means output. But your book uses O, so we'll just stick with that for the PowerPoint. So output is equal to a function. That F just stands for a function. A function just means some generic equation. I'm not going to ask you to produce that equation, but I will say that if I gave you the inputs that the farm had, how many workers, how much land, how much seed, how much fertilizer, what their production methodology would be, the equipment available, things like this, the growing season. We could even model weather into this, right? What's going to happen with those natural resources? How much water will we get? How much water will we have to pay for, right? In California, we tend to pay for water. Other parts of the country, we tend to just hope it falls from the sky, right? So, but if I gave you all that information and you had it in a spreadsheet, I would hope with some training and experience, not just in general, but I hope you would recognize that you could actually use that data to create an equation that said, based on this much labor, capital, land, and management, we get this much output, or we predict this much output, right? And you'll see farmers do this all the time. They'll produce yield estimates, at least, well, let's segment this out. My grandfather did not produce yield estimates. He just went off of what he learned back when he started farming with his father. And he would look at what the Farmer's Almanac said and the weather models from the government said, and he'd say, oh, it looks like it's going to be an okay season. And he'd guess on average, well, if I plant this many, he did corn, cantaloupe, and tomatoes were the big crops in Pennsylvania. And he'd say, look, if I plant this much corn, this is what I expect to get in terms of yield. I have a friend who's an almond grower primarily, and he's out in the foothills. And he's a retired tech guy who became a farmer. And he actually has very sophisticated models, right, that are using the numbers. And he can project based on what he's doing with water and everything else. And he gets very accurate yield estimates, right? And so many farming, especially commercial farming operations, have got quite specialized and quite talented in being able to estimate their yields, right? And maybe the most important thing is coming in with yield estimates that are close, but if they're off, they tend to be lower, not higher, because it's better to have more yield than you planned on than less, right? From a planning perspective. So we just say that this production function is your output is equal to some mathematical relationship between the land, labor, capital, and management that you have. Now, we can allow more than one variable to change at a time, but that involves some more advanced mathematics than most of you probably have for this class. And so we're going to assume that all of these inputs or resources are held constant, and we're only going through this chapter to change one variable at a time. We're going to change labor, but you could go back through all of these examples and hold labor constant and then change capital, change land, change your management amounts, right? You can play with these numbers. So we're just changing labor, and we're going to assume everything else stays constant. And this is not realistic in the real world. We change more than one thing at a time. We just don't have the mathematical tools at this time as a class to go forward with that. And that's for a more advanced economics course. So here's a hypothetical production relationship for Top AG Incorporated. And so we're going to plot these points on a graph in the next picture. And so, in fact, let me take it forward. So you can see we're just plotting points A through J. And what we've got on these columns, column 1 is just our daily labor use. It's how many workers we have, right? So we're going to, once again, change this worker output, and we're going to see different levels of output that we can achieve in product, right? So 2 is just per the number of workers in column 1, how much output we get of whatever product we're growing, right? And We aren't defining it in this example, but let's just say this is tons of corn, for example. So you have 10 labor used, and we're also not really defining that. Depends on your business model. You might be paying workers by the day. You might be paying them per pick. You might be paying them a salary. It could be all over the place. So for your business, you would determine, are you doing man hours? Are you doing man days? Or are you using some other metric for measuring your labor? So let's just assume this is the hours of labor used per day. So if you have 10 labor hours, you get 1 unit of output. You have 16, you get 3. 20, you get 4.8. So column 3, we're going to derive the marginal physical product. And we do that by taking the change in column 2 divided by the change in column 1. And so if you do that, you end up with 3 minus 1, which is 2, and 16 minus 10, which is 6, right? And so you have 2 over 6, and that gives you 1/3, or approximately 0.33. And you can do this for every line going down. And due to the way this is typed and the way the textbook manufacturer put it together, they're just putting it online. But technically, you can shift this up by half of a level, because 0.33 is really the change from A to B. 0.45 is the change from B to C, right? And so really we would want to shift this up by half a line, but that's, let's just say I've tried to do it before. It can be a little bit of a pain in the rear to create a table like that. Spreadsheets don't work that way, right? So it is what it is, but just letting you know. But normally textbooks, or when we print it out as an economist, you're going to print it out in this way. We can then go from the marginal, which marginal just means the change, right? Marginal is just a change from one point to the next. In this example, we're moving more than one. And sometimes traditionally in textbooks, they might say, look, everything in column 1 is just 1. So your labor use would be 1, 2, 3, 4. Well, then it's just the change in here divided by 1, right? But, I actually like the book doing it this way. We can then calculate the average physical product. This is what the number of workers produce on average. And you're just going to take 1 divided by 10. So you take that column 2, divide by what's there. And since this is the average, it is a point estimate. So you're getting an average for A, an average for B, C, D, E. And you're saying the average worker produced 0.1 units of corn, or whatever our output level is. The average worker here produced 0.19, right? And so the goal of all of this is to figure out how much do we produce and how many workers do we employ, right? These are the 2 things we're trying to learn from these mathematical relationships. And so we can see that as we add workers, we get more and more production until we hit point I, and then all of a sudden it goes negative. And I want you to think about why that might happen. So imagine you have a kitchen. You run a restaurant. So initially your kitchen works. If you have 0 workers, you don't get a lot of output. So you have a fixed grill size, you have a fixed refrigerator, a fixed amount of counter space. As you add workers into that kitchen, you get more and more efficient. You get more production, more productivity. But what happens if you have too many workers in a kitchen? All of a sudden, the cooks are getting in each other's way. The workers aren't as efficient. It slows them down, and you actually lose production in total, and you actually lose production at the margin, and your average productivity, or your average physical product, goes down the 4th column. And so this is something we call diminishing marginal productivity, and you can see it on the graph when we go to point I to point J, that we've hit our peak, and now from here on out, we're just going to get less and less product as we add more and more workers. So total physical product is at its peak, and we saw this with demand and utility as well. We saw total utility eventually declines because of diminishing marginal utility. And we know that when marginal utility hit 0, total utility was at its peak. Same thing here. When total physical product is at its peak, the marginal product curve will actually be at its minimum or at zero. Not its minimum, but at zero. So anyway, so that's how we do that. And the relationship comes from column 1 and 2. We're just plotting the points. So defining those terms in 3 and 4, once again, marginal physical product, it's the change in output divided by the change in the input used. And average physical product is going to be a point estimate, and it's just the level of output divided by the level of input. So when we graph the marginal physical product, we end up with, or when we start to graph the marginal physical product, we're going to look at the change in both directions to graph it along this curve, right? And so the marginal physical product in column 3 in table 6.1 would be 0.45 as labor goes from 16 to 20. Output would rise 1.8 units as labor increases by 4. So, but we'll do that in the next one. Boom. So once again, this is just the definition of the law of diminishing marginal returns that I talked about earlier. It's that change in marginal product where eventually it goes down. So I'll let you guys read it. I'm not going to read it to you, but what we know is that as we add more inputs, those inputs lose their bang for the buck, right? As we add more and more. The reason that happens, I don't know that your book really gets into it well, but the reason that happens is because we're fixing the quantity of all of the other inputs. So eventually we run out of seed for the workers to use, we run out of land, we run out of equipment, all these things. If we allow everything to grow, we could escape the law of diminishing marginal returns until we hit the mega farm that was bigger than the planet, and then we are at absolute scarcity limits, and then diminishing marginal returns occurs. But businesses can add more and more other inputs as they add the primary input to offset this. But once again, the math for modeling this a little more than we can do in an introductory course. So we can then look at our average physical product, and it's just the relationship between our labor use and our output. Once again, we just get it from the points on the graph, or really it's easier to derive it from the table and then draw the points on the graph, in my opinion. So if we plot the marginal physical product curve, once again, we get this place where we are going up, and then it's going down, 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 until eventually we're at this point between I and J where we're at 0 marginal physical product, which is approximately equal to where our total product would be at its peak if we had it on this graph. Remember, our total product was at its peak at I. So somewhere right here, we're right around the peak, and then we start declining again on that total physical product curve. So marginal physical product curves, not always, but almost always increase initially, and then they decrease because of the diminishing marginal productivity. Average physical product is more shallow. Just an observation. So is what it is. So average physical product curve increases up to a point where it's intersected by the marginal physical product curve. And then it's going to decline after that point as we use more labor to produce more output, right? The fairly simple relationships. So we have these stages of production that have been on the graph up to this point. So stage 1 occurs where output per unit of input is rising, and it's going to end where marginal physical product equals the average physical product. So this is stage 1 of production. So this is really what we'd call that kind of growth stage. We're still getting more bang for the buck. One way of thinking about this is your marginal physical product is your grade in this class. Your average physical product is your GPA. So one way to think about it is if your grade in this class is higher than your GPA, then your GPA is still going up. That's stage 1, growth phase. If your grade in this class is the same as your GPA, right, your average grade point average, then you're going to end up with no change, right? in this. When your marginal physical product, we don't really have this, you can't get less than 0. So you don't end up with stage 3 in grades. My example falls apart, right? So, but in farming, we could actually go to a point where we're having negative marginal physical product, right? Those extra workers are actually losing us resources. I don't think, it really couldn't happen in the grade thing. So with our grade example, we'd have stage 1 and stage 2. That's it. But we can actually have stage 3 where we're actually generating potential losses down the line. Depends on our cost structure. So there's no sense in stopping production in stage 1, right? You're growing, you're making more. You might as well add more workers because your output per unit is unit of input is still going up. It also makes no sense to operate in stage 3 as the change is going to be negative. So what we're really looking at is the stage 2 to determine what's going to be the optimal amount of workers to use to maximize production and maximize income, right? We're going to end up somewhere in here in that stage 2. So if we're operating in stage 1 and stage 3, there's not a lot of economic sense. Stage 1, you could just add more workers and make more money. Stage 3, why wouldn't you cut off workers and make more money, right? So where we're going to produce is somewhere in stage 2. To answer the question of how many workers we need, how much we're going to produce, we have to account for the price of the product that we're producing. We also need to account for the cost of our input, and in this case, that input's labor, so we need to know wage rates, right, to make sense of this. So some more key cost relationships. We've got marginal cost. Once again, anytime we see marginal, it's just the change in something divided by the change in something. So in this case, it's the change in total cost divided by the change in the output level. The average variable cost is the total variable cost divided by the output, and the average total cost is the total cost divided by output. So there's some words and terms in here that aren't defined in this PowerPoint, but let's talk about what a variable cost is versus a fixed cost. So in an agricultural production, in any production, variable costs are inputs that as you change them, change the amount of production in the short and medium run, right? So you have some variability. So I can add more workers. I can add more seed, right? In the short to medium run. Even in the long run, I can add more, right? Fixed costs, which we're not analyzing right now, but fixed costs are costs that don't change with the amount of output, right? So if I have land, my land has the same cost, real or implied, right? Regardless of how much I produce. There are some land contracts that might involve payment based on production. That payment that's based on production levels would be a variable cost. So you can imagine you're the owner of a piece of property and you say, look, I'm going to charge you $500 an acre. And then if you achieve greater than this production level, I'm going to charge you a bonus amount. That bonus amount would be the variable cost. The cost for just renting the land would be your fixed cost. Any machinery you buy is a fixed cost, right? So you buy that tractor, it's a fixed cost. No matter how much you produce, the tractor still costs you money. The gasoline or diesel that goes in the tractor is a variable cost. Total cost is just a summation of your variable and your fixed costs, right? So anything that you have contracts for tends to be a fixed cost, but you know, there is sometimes a relationship between those fixed costs and how much you can produce, but you need to negotiate a new contract, which is something that's a longer term relationship. So here we've got the table from earlier, and well, it's a different table, but anyway, we've got this table from the company from earlier, and we've added in the cost structure. And so just going through these columns, we've got our total output. We've got 1 unit of output, 3 units, 4.8. We've got our fixed costs. Remember, these don't change. They're the same regardless of the level of output. So for this firm, they pay $100 in fixed costs, or 100 times 1,000. So 100,000 in fixed costs. Depends on how this spreadsheet was running. Your variable costs, you're just taking column 2, the fixed costs, or sorry, your variable cost, you're taking 2 and dividing by 1. Interesting. Anyway. Okay, I paused it for a second to see what was going wrong because that threw me for a little bit of loop. Column 3 should say average fixed costs because you're taking your fixed cost dividing by your output, right? So we're taking 100 divided by 1, that's 100. 100 divided by 3, 33. 100 divided by 4.8. We'll assume the math's right, although they had a typo, so maybe it isn't. You want to go through and double check, go for it. Then we've got the variable cost for the firm that's just given to us. We could have a model where they tell us, look, your cost of labor is this is how much labor you're using, and you multiply the labor times the labor cost to get your variable costs. Your average variable costs are just taking column 4, those variable costs, and dividing by the output again. So 50 divided by 1, 50. You've got our total cost, which is just adding the fixed and the variable, adding 2 and 4. We've got our average total cost, which is just taking the well, I don't like the way they're doing it, but maybe I'll pause it and see, but I'll let it to you guys. But if we have average total costs, really the way I do it is take column 6 and divide by column 1, right? So we get 150 divided by 1, 150. 180 divided by 3, 60. 200 divided by 4.8, we'll assume 41.67. But let's see if their method works. We've got, and it should actually 50 divided by the average variable costs. Well, that's average fixed cost. We already said 50 divided by 100. Yeah, their slide makes no sense. Gotta wonder. I'm going to go on a little soapbox. Gotta wonder why you guys pay publishers for textbooks. It's super frustrating to me. When I teach my general economics courses, I use a free textbook. One of the reasons I use a free textbook is when you have mistakes like this, you can't complain, right? As an instructor or a student, because what did you pay for it? Nothing. You guys paid 40 to 80 bucks for this book, depending where you bought it. Should have been hopefully 40 bucks. You pay 40 bucks for this book, and what are you getting? Yeah. Anyway, is what it is, but yeah, you take column 5, you divide by 3, 50, that should be 0.5, doesn't make sense. So, and it wouldn't be average total cost. Now we could take, yeah, no, I don't know. They're screwed up. Anyway, our marginal cost though, fortunately that is correct. We take the change in total cost and we divide by the change in output, right? And so we're going to look at our marginal cost, and we say, okay, we're going from 150 to 180. That's a 30 unit change. And we're going from 1 to 3. And so that's a 2 unit change. And so we've got 30 divided by 2, which is 15. We're going from 180 to 200. That's a 20 unit change. And we're going from 3 to 4.8. That's 1.8. So 20 divided by 1.8. I'm going to do the math, make sure their math is right. And I got 18. So we said that was going to be 20 divided by 1.8. Oh, helps if I do that. And I get 11.11. So the math is correct, thankfully. Once again, this marginal cost is really between A and B, B and C, C and D, all the way on down. And what we can see is this change in what we can see is our total cost structure and our marginal cost, right? And so think about it from this perspective. If you're a farmer and you're looking at maximizing profit, profit is just the difference between your revenue and your costs, right? And so you're going to say total revenue minus total costs. And the largest spread gives you the point of production that you want to maximize your profit at. Okay. Let's go to the next. Okay, so these are our cost curves. So we've just graphed out the average total cost. We've graphed out the average variable cost, the average fixed cost, and the marginal cost. All these costs are graphed out. And we're just using the data the aligned points from the previous table, right? So we're just graphing those points. So we graph those values. The marginal cost curve rise as after point D as the marginal physical product falls. So this is our falling point for marginal physical product. The average variable and total cost curves fall and then increase as average physical product would have climbed if we lay that over this graph, which you could do. So we assume that our firms are price takers. That's a result, not a condition, a result of perfectly competitive markets. It means that you're a price taker. You don't get to set the price of your corn. You just take what the market pays you, right? So you go down to the local grain mill or the cooperative and you say, this is how much I get. Or you go into one of the markets on the CME I don't have exposure to this. I trade a lot of commodities, but I'm not a big enough trader to trade on local markets. But you can go to different grain exchanges electronically and you can see what they're selling and you can sell your grain there, right? If you're a farmer. So we assume the price of corn per bushel is $3. That number is a little low. Currently, I think we're what I see, 5, no, that's new crop. Current crop corn's like $5.96 a bushel, so almost double. Think about the inflation since 2018. We've almost doubled the price of corn. At one point it was $9 a bushel, which is crazy. So anyway, earlier this year and last year. Marginal revenue represents the change in total revenue per unit sold. The marginal revenue for selling another bushel of corn is therefore equal to just $3. So every bushel is $3. The more you sell, you just get $3 for each bushel. There's no quantity discounts or quantity bumps, right? For a price-taking firm. Average revenue is just the total revenue divided by your output. So if the firm produces 100 bushels of corn at $3, total revenue is 300, but you divide by the 100 bushels and you get the price per bushel or $3. So if we have perfectly competitive markets, then we can say that these relationships are equal to each other, which is that price is equal to our marginal revenue, which is equal to our average revenue. That only occurs in perfect competition. It's a result of that. And so when this farmer is looking at their decision, they have a marginal revenue curve that is flat, right? This is how much you're going to make, is just 30 per bushel, right? You're going to, or whatever we said it's going to be, right? So you're going to make that price. That's what you get. So we have our average total cost curve. So let's break this down. So first off, profit maximizing condition for the firm we said is when the spread between total revenue and total cost is at its maximum. Another way of putting that, I'm not going to spell it out because I'd have to use my whiteboard, but is that marginal revenue equals marginal cost. And we can see that on this graph where we're at this point where our marginal cost curve intersects our marginal revenue line, right? So we've got this marginal revenue line of 45. Anyway, so we've got our marginal revenue line at 45, marginal cost equal 45 at this point. So this is our output maximum. This is the most output we're going to have. And so this tells us where we maximize profits. Now, if our average product, so we're going to look where we intersect the curve right here, and we're going to say, okay, our output max intersects our average total cost down here. And so one way of saying it is the cost per unit is lower on average than the amount we're getting for it. And so what do we have here? This is our profit zone, right? We're making money here. And so if we were going to break even, we'd be producing all the way down here where marginal cost is equal to our average cost. And we would end up breaking even on this. And I'm not sure what they've got the OSD standing for right now. I'm blanking on it, so we'll come back to it. But anyway, we've got the marginal cost curve, we've got average variable cost, average total costs. Anytime our average cost is less than we sell the item for, we make a profit, and the profit is this rectangle, right? Because we're going to produce all the way out here. Let's call this 11 point something, and we're going to get, so 11 point something times from 30 to 45, so 15. Pretty good money. So break-even price occurs at the price of break-even. So if the price is down here, this is where we would break even, where our average cost is right here. And then the price SD, oh, this is our shutdown condition. You guys can look at the graph. Shutdown condition is just where the firm can't cover their variable costs any longer. If you can't pay your workers, they're not going to work. If you can't pay your seed manufacturer, they're not going to give you seeds. If you can't pay for the lease on your tractor or your land, the bank's going to take it, right? So your shutdown condition occurs when you can't even cover your variable costs of staying in business. Can't pay the government taxes. So if the price falls to here, where this price would intersect your marginal cost curve, this is where you end up. Where your average variable cost curve would hit your marginal cost curve, then this is the output that you would produce, and this is where you'd be shutting down. So you'd say, look, I produce this, anything more, any lower price or any less production, I need to close my business. Because this is the point where you just can't stay in business. This will take a step back. Everyone wants to make money, but sometimes you lose money in business, right? And your goal is to lose as little as possible. You're going to still produce losing money. The question is, how much are you going to choose to produce? How much effort are you going to put into it? This shutdown point is the point at which the market makes you go out of business. The bank takes everything, or you stop having workers, you stop having supplies. Okay, the following input-related derivations also play a key role in decision-making. So our marginal value of product is equal to the marginal physical product times its price. And we've got this other relationship, which is our marginal input cost, which is our wage rates, our rental rates, and et cetera. So we've got the same company, we've got its usage of labor, we've got the marginal physical product. These numbers look fairly similar before. We're going to multiply the marginal physical product times the price of the good to get the marginal value of our product, right? So we're saying we get 45 times the amount of product. And then we've got our wage rate. This is constant at 5. Marginal net benefit, we're just taking the 1485 that we calculated minus the 5, right? Column 4 column 3 subtracting column 4. 38.25 minus 5, 33.25. And the cumulative net benefit is just how much we're making along the way, adding these numbers up. And so if you're producing, and this is net benefit, another word for this is profit, how much do you want to produce? How many workers do you want to use, right? And so you're going to keep adding workers as long as you're making money. And we can see, where do you stop making money? It's going to be at point G. You're at 79. If you go to point H and you hire those 10 more workers or use 10 more hours of work, you lose money, right? No one wants to do that. So you're going to stop production at 40 units of labor. In my mind, when I was prepping for this wage rate being constant doesn't appear, well, I guess we're okay, because we're calculating the marginal physical product, which is how much one more worker lets us produce. So one more worker from A to B, we get 6 workers, but we get 0.33 per worker, and we're paying that worker $5 to do it. So that worker is producing 0.33 units times the $45 per unit. And that means they're producing $14.85 in revenue, and they're costing you $5, right? So your revenue minus your cost, and this is our only cost in this model, right? Is this labor cost. So that's what's going on there. So our marginal value, The marginal value of product curve looks similar to a marginal physical product curve. That's because it's just the marginal physical product curve multiplied by a constant, which is 45. So it's going to be the same, just scaled up or down based on the pricing. Well, scaled up in this case. And we can see here's where our wage rate is. One way of thinking about this is our marginal cost, and this is our marginal revenue. And so our marginal cost equals our marginal revenue at 40 units of output, or 40 units of labor usage. And so we're going to have 40 workers. So this profit maximizing firm doesn't want to use less than 40 workers because you'd make more money, and you don't want to use more than 40 workers because you're going to lose money. So the area below this curve and above the wage rate is total cumulative profit. And so the total profit is just going to be this area from B, C, D, E, F, G, that curve, down to the wage rate, right? That's our cumulative profit region if we wanted to produce it geometrically through a series of calculating triangles and rectangles and quadrilaterals. If we use less labor, then the firm's ignoring potential profit. If they use more labor, they're losing money. So the level of profit maximizing output, our output max, is where our marginal revenue equals the marginal cost. And it's going to correspond directly to the amount of labor that we're going to use to maximize production based on our wage rates and our revenue. So our output at maximum from our production function is equal to a function of our labor at maximum amounts, holding capital, land, and management as categories fixed, the amounts we're using. So that's just a summary of what we've discussed, and really not much to say on that. Anyway, if you have any questions, I know there's a lot in this. Read the chapter, listen to this. I could also, if anyone needs help, I could send an email. I could put up a PowerPoint on just from general economics, or not a PowerPoint, but a whiteboard discussion from my general economics course that I've given in the past on how to calculate how firms make decisions. It's a little more involved and kind of goes through more numbers and more examples. So feel free to email if you'd like me to try to post a link to that YouTube video as well. Or you could go through my YouTube channel and look for it as well. It's publicly available. So anyway, if you have any questions, as always, text message, phone call, email, and I'll try to get to you as quickly as possible. So thank you all very much and have a good evening.